Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another topic in algebra, particularly on variation problems or variations. And this is an important topic for beginners, especially those who want to aspire to become future engineers. So these are the principles. You need to translate the statements, the language of variation to algebraic equations. The relations are normally stated in words. Then all you have to do is interpret that, translate that to algebraic equations so that there's a possibility that you can successfully answer the problems on variations. So first type of variation is the direct variation. And whenever y equals kx, the equation is stated in one of the following ways. So this is the interpreted, uh, or this is the translation of this language. So y is proportional to x, y y varies directly as x, y is directly proportional to x, and y varies as x. Simply y varies as x. So all these statements correspond to this equation here. So as simple as that. Examples of these variations are the following. So by the way, in y equals kx, k is called the constant of proportionality or the constant of variations. So examples would be distance equals speed times time. It may be the speed that is constant and time the variable depending on the situation, or it may be the time that is constant. You fix the time, then the speed is the variable, vice versa. Then pressure at a point in a liquid is specific weight or unit weight or weight density of the liquid times the depth or vertical distance of that point from the free surface exposed to zero gauge pressure. So specific weight is in newtons per cubic meter or kilonewtons per cubic meter, or in English units, that should be in pounds per cubic foot. For water, for example, 62.4 pounds per cubic foot, or water 9.1 kilonewtons per cubic meter. Circumference of a circle is pi times the diameter. So pi is the constant, the diameter would be the variable, as well as the corresponding circumference. Then inverse variation, whenever y equals k over x, the equation is stated in one of the following ways. Is inversely proportional to x, y is inversely proportional to x, y varies inversely as x. Of that statement. So examples of this is from this equation here. Time is distance over speed. So if the distance is set fixed, then you have to measure the time in covering that fixed distance so that uh, you can have the speed also, which can be computed. So, or speed equals distance over time. The distance is again fixed. Then All you have to do, you can compute for the speed. Then you measure correctly, accurately as possible the time covered in running this distance. Then this is Boyle's law by considering isothermal condition. Temperature is held constant. Pressure is inversely proportional to volume, or pressure times volume equals constant. So volume is also constant over pressure. So volume varies inversely as P also for that case. Then joint variation whenever Z is equal to Kxy, the equation is stated in one of the following ways. So Z varies jointly as X and Y. Z is indirectly proportional to X and Y. Z is proportional to X and Y, or Z varies as X and Y. Example of this variation would be the following. Volume of right circular cylinder, pi r square h, where r radius of the base and h the altitude. Then lateral area of a cone, which is this. The lateral area does not include the base area, which is circular. So it is pi rl, r radius of the base, then l the slanted height. Then the zone area of a sphere, this part of the sphere, is 2 pi rh. So the zone area varies directly as the radius and h, where the radius of the sphere is that, and h is this distance here. Then combined variation, this is the last. Whenever w equals kxy over all over z, the equation is stated in the following manner. By the way, in these variations, it doesn't mean that the exponent of the variables are always 1. It may be 1, it may be cube, it may be 2. So here also. So y varies jointly as x and y and inversely as z. Then example of this is the Newton's law of gravitation. Another example is the Coulomb's law in electrical engineering. So Newton's law of gravitation, the gravitational attraction between two objects is equal to the universal gravitational constant, capital G, mass of object 1, mass of object 2, divided by the distance between their centers square, the square of the distance of their centers, where G is 6.674 times 10 to the negative 11 newtons meter square per kilogram square. By the way, 6.6743 times 10 to the negative 11 Newton meter square per kilogram square. So that's it for these variations. Then let's have examples. The period, which is the time for one complete oscillation of a pendulum, is directly proportional to the square root of the length of the pendulum. And a pendulum of length 8 feet has a period of 2 seconds. Express the number of seconds in the period of a pendulum as a function of the number of feet in its length. Then find the period of a pendulum of length 2 feet. So first, let's interpret this statement. Period is directly proportional to the square root of the length. So period denoted by capital T is constant of proportionality K, then square root of the length, square root of L. Then given the condition 2 seconds the period, then the length is 8 feet. So from there we can solve for the constant. So 2 equals K square root of 8. So K is 2 over 2 square root of 2. So that's square root of 2 over 2 seconds per foot to the 1/2. Therefore, the formula for period is T, the constant square root of L. So that in part B, find the period of a pendulum of length 2 feet. So period equals constant square root of 2 over 2 times square root of 2. So that would be 2 over 2 or 1 second. So problem 2, to make the file small and so that I can upload the video easily. I prepare the solutions not anymore in animated form. Introduce letters if necessary and express the relation by an equation. By the way, if you want to anticipate the solutions to these problems, you can. By pausing the video, do not look at the answers. You just interpret, then that's it. You are ready for variation problems. W varies directly as U and inversely as V cube. So interpretation, equation, W equals constant of proportionality times U divided by V cube. So that's the equation. G is proportional to X cube and Y square. So Z equals constant X cube Y square then divided by Z to the fourth. So that's the interpretation. V varies as X and Y and inversely proportional to W. So V equals KXY over W. KXY over W. K, capital K varies jointly as square root of S, T, and U to the 3 halves. So jointly, so in product form, so K is another constant. So I will introduce it with C instead of small letter k. You might be confused. So anyway, that's the constant. Then square root of S times T times U to the 3 halves. E. Z varies inversely as x squared, y cubed, and w to the 1 half. So z is equal to constant all over x squared, y cubed, w to the 1 half. The area of a triangle is proportional to its base. So area equals constant times b, where b is the base. Part G, this one. 2f z plus 5 is proportional to x minus 3. So that is z plus 5 is equal to k, constant of proportionality, then times x minus 3. So this is 2g already. Then h, the volume of a sphere is proportional to the cube of its diameter. So volume equals constant times cube of the diameter. Then I, the volume of a specified quantity of a gas varies inversely as the pressure applied to it if the temperature remains constant. This is Boyle's law. PV equals C. So in this case, volume is constant over pressure. So volume equals constant over pressure. 2J. The weight of a body above the surface of the Earth varies inversely as the square of the distance of the body from the Earth's center. So W, weight, is constant of proportionality divided by the square of the distance of the body from the Earth's surface. So D square, where D is the distance. K, the maximum safe load of a horizontal beam of a given material supported at the ends varies directly as the breadth and the square of the depth, and inversely as the distance between the supports. So load P is equal to constant of proportionality. The breadth varies directly as the breadth and the square of the depth of the cross section, then inversely as the distance between the supports, which is denoted by L in this case. 2K, that's 2K. 2L, the lifting force, this is called lift force in fluid mechanics. The lifting force exerted by the atmosphere on the wings of an airplane in flight is proportional to the area of the wings and the square of the plane's airspeed. So lifting force F sub L, constant of proportionality. So it varies with the area and the square of the uh, airspeed of the plane. So square of the airspeed. Then the index setting F for a camera lens varies inversely as the diameter of the aperture when the distance of the subject is at infinity. So that's the condition, but it is interpreted simply as F equals constant of proportionality divided by the diameter d. Then finally, if one body is resting on another, the force of static friction is proportional to the pressure between the bodies. So that pressure is denoted by N, the normal contact reaction between two bodies. So force of friction equals constant times the uh, pressure or the normal contact between two bodies. So that's it for this video.